channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. हम कंप्यूटर की ग्राफिक्स की क्लास कर रहे हैं जो कि क्लास नंबर 13 है. ऑलरेडी हम 12 क्लासेस कर चुके हैं. 12 क्लासेस में हमने यूनिट 1, यूनिट 2, यूनिट 3 एंड यूनिट 4 पूरा कंप्लीट कर लिया है और डिटेल में उसको डिस्कस भी कर लिया है. उसके साथ साथ हम जो क्लासेस कर रहे हैं ऑल शॉर्ट क्वेश्चंस ऑफ 2 मार्क्स पॉसिबल क्वेश्चंस दैट वी हैड डन अबाउट यूनिट 1 का हमने कर लिया है, यूनिट 2 कर लिया, यूनिट 3 भी कंप्लीट कर लिया है. यूनिट 4 में हम मेमोरी बेस्ड क्वेश्चंस कर चुके हैं और एप्लीकेशन बेस्ड क्वेश्चन लास्ट क्लास में हमने स्टार्ट किया था. आज उसी को कंटिन्यू करते हुए फिर हम आगे बढ़ेंगे. उसके बाद हम अब इवैल्यूएशन बेस्ड क्वेश्चन भी करेंगे एंड इन दैट सेम केसेस फर्स्ट ऑफ ऑल इट्स अ ह्यूज रिक्वेस्ट फ्रॉम माय साइड टू ऑल द व्यूअर्स. Please go through with the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. In respect towards the application based question, as I told you, we'll start with for unit 4 we have, and that is going to be discussed here. So here we'll go ahead with a question that is after the application based questions that we had discussed the two of the questions here, and that is the first question we'll discuss about it here only, that is the Z buffer algorithm that allow 128. I just tell you the question, then I will be writing it out. The Z buffer algorithm allow 128 as depth value level to be used, and how much would a 512 cross 512 pixel display that required to store the Z buffer if the scene consists of 14 objects that it is. So the 128 depth value levels to be used, how much would a 512 cross 512 pixel display require to store Z buffer if the scene consists of 14 objects. Okay, so here the solution for this we have. For this, that the 128 depth value levels would require 7 bit of memory, that is of 2 to the power 7. We'll find it out because they had mentioned you 128 that a depth value. So the depth value level that would require, and for the finding out that 128, so it would be your 2 power 7, which is equals to 128, that to represent each Z value. And in this, to find it out, the formula that 7 into the 7 into 512, which we had been given here, multiply 512, and that is upon 8. So here in this case, that when we are going to solve it out all, then we will get it as your 229.376 KB. Okay, now we'll go ahead with other one, and that what we have to discuss as well. As if of 8, we'll talk about it as this 2 4s are 8, 2 2s are 4, carry 1, and that is your 2 5s are 10, and then we have carry here 1, and then 2 6 are 12, 256, and then we have cancel it out, 2 2s are 4, and then we have 2 1s are 2, and then 2 2s are 4, and 2 8s are 16. Then we carry out, cancel it out, 2 1s are 2, 2 6 are 12, and that is your 2 4s are 8. So that 2 has been cancelled, this 8 has been cancelled, so you have to multiply 64 by 512 7, then you will get it out as an answer. Otherwise you can just multiply and then divide it by 8. It could be also solved here. Now the other question has been arise, which is another one, and that what we have to discuss, that at surface P, if the surface normal light vector and the site vector that are n, so that are n here, and that is where vectors n that is equals to j, l equals to minus I plus 2j minus k, and s is equals to I plus 1.5j plus 0.5k, and find the value of the reflected ray. We have to find out the value of the reflected ray. Let's go ahead with the question here. At surface P, if the surface normal light vector and site vector are n, that is equals to j, n equals to minus I plus 2j minus k, and s equals to I plus 1.5j plus 0.5k. Find the value of reflected ray. So the solution for this we have, that is here, that is n bar equals to j, L bar equals to minus I plus 2j minus k. And then we have here, which is so that s bar equals to I plus 1.5j plus 0.5k. In this we can find the reflection vector using, that is r equals to 2n and l minus l, and that is equals to 2j 2 minus I plus 2j minus k. We are putting the value here, and in the same cases when we'll find it out, it will be 4j plus I minus 2j plus k, and here in the r equals to I plus 2j plus k. This will be the right answer. Now we'll go ahead further with another question, that is to calculate the third order basis function, which is of n I comma 3, and that I equals to 1 2 3 4 with an open uniform kind vector of mu that is less than equals to 0, that is greater than n equals to 0 and less than equals to 1 here. So we'll go ahead with the question here. Calculate the third order basis function n comma 3 mu I equals to 1 2 3 4 with an open uniform kind vector for 0 equals to mu, this equals to 1. So for that we have to solve it out, where n 3 comma that 3 comma 1, which is mu equals to 1, and that is has been representing here, and then of n comma that I comma 1, that is equals to 0, I does not equals to 3, and that has been representing. We will go ahead with the solution. n 3 comma 1, that is of mu equals to 1, and I comma 1 mu equals to 0, then I does not equals to 3, and 2 comma 2 mu equals to 1 minus mu, and 3 comma 2 mu equals to 4, and 1 comma 2 mu equals to 0, and 1 comma 3 mu equals to 1 minus mu per square, and where I does not equals to 2 or 3. So here in this, the another one, n 3 comma 3 mu, that is your mu square 1 2, which is n 2 comma 3 mu, where p, that is sorry, mu 1 minus mu plus 2 minus mu upon 2. So for that we'll find it our value here. That is n 1,3 equals to 0. I is not equals to 1, 2, 3. Okay, so here the evaluation based question we'll talk about it. In the evaluation based questions here that we deal about it, the question is, the first question of evaluation based of 4 unit that we have is that to determine the name of the buffer method from a given data. You have to find out the buffer method from a given data. This algorithm compares the surface's depth at each pixel positions on the projection plane. It is usually implemented in the normalized coordinate, and as well as that the surface depth is measured from the view plane along the z-axis of the viewing system. So I repeat the question here, that to determine the name of the buffer method from the given data, that the algorithm that compares surface's depth at each pixel positions on the projection plane. It is usually implemented in the normalized coordinate. The surface depth is measured from the view plane along the z-axis of the viewing system. So the answer is we have is your depth buffer method. So the second question of the session that we have here in reference towards the evaluation based questions, that what we have to discuss as well, and that is the question is to identify the type of the approach of hidden line. You have to find out the approach of a hidden line. It is implemented in the screen coordinate system, in which the objects are viewed and its visibility is decided point by point at each pixel positions on the view plane. So I repeat the question, that identify the type of the approach of hidden line, and it is implemented in the screen coordinate system, in which the objects are viewed and its visibility is decided point by point at each pixel positions on the view plane. The answer we have is your image space method. The other question, to predict the name of the method of hidden surface removal, and that is of scanline 1, scanline 2, where the answer is the scanline method. The other question we have, that the equation that can be represented as the follows. So the equation we have, which is x square upon rx plus y square upon ry and plus z square upon rz, that is equals to 1. So the equation that can be represented is x square upon rx plus y square upon ry and z square upon rz, that is equals to 1 here. And you have to find out the type of quadratic surfaces, those equations in the given above. So find out the type of the quadratic surfaces, whose equation is given here. So in this that is the answer is ellipsoid surfaces. In ellipsoid surfaces, the answer is ellipsoid surfaces. The other question we'll talk about it, which is the another one, that consider the following, that the predict the type of the order parametric continuity. So we have to predict the type of the order of that is your parametric that is continuity. This is a sort of figure, and that is your first order parametric continuity. We have this is first order parametric continuity. Now we will go ahead with the detail, because we had completed unit 4 here, And now we'll discuss some of the examination questions in reference to words. If it is possible, I will be telling the answer as well, because we'll discuss many of the questions here. So the first question paper that we'll discuss, that to attempt any two parts of the following has been the question here, and that is, the question is arise like write the merits and the demerits of LCD, which is liquid crystal display. That is being asked of 6 marks. So we'll talk about it. So merits and demerits. First we'll discuss the merits, and then after that we can discuss about the demerit, but we'll discuss both in the detail so that it could be possible here and to discuss as well. So first we'll discuss merits LCD. You can say that LCD merits. Okay, so the merits of LCD here that we have, the first we have as your, that is brightness. Merits is your brightness. In brightness, the brightness that produces a very bright image due to the high peak intensity, very suitable for the environmentals that needs to be brightly lit here. Second merit of LCD we have is your emission. In the emissions here, that produces considerably lower electric, magnetic and electromagnetic fields than CRT. The third we have is geometric distortion. In geometric distortions, no geometric distortions at a native resolution, minor distortion that can occur for other resolution as well. The fourth we have is your power consumption. In power consumption, energy efficient consume less than 1/3 that the power of the comparable CRT, that consumes less electricity than the CRT and produces a little heat as well. The fifth we have physical aspect. In the term of physical aspect, that take up about 40% less desk space. LCDs are thin and compact. The sixth we have as your screen shape. In the term of screen shape, that completely flat screen. The seventh we have as your sharpness. In sharpness, that at a native resolution the image is perfectly sharp. Adjustments are required at all other resolution, which can result in measurable degradations to the image. So if they had asked you about the merits of LCD, you can just tell you there are the 7 merits: brightness, emission, geometric distortions, power consumption, physical aspect, screen shape, and as far as the sharpness. Now we'll talk about the LCD demerits as well. So in the terms of LCD demerits, first we have aspect ratio. In the aspect ratio here, that the aspect ratio and resolutions are fixed. The second is black level. In black level, that not proficient at producing black and very dark gray in the standard configuration, not appropriate for the use in a dimly light and a dark condition. The third we have is a contrast. In contrast, that lower contrast than CRTs due to the poor black level. The fourth we have color and grayscale accuracy. So color and gray scale accuracy here, the color saturation is reduced at low intensity level due to the poor black level. Image are satisfactory but not accurate due to the problem with the black level, gray scale and gamma. The other fifth one we have is your cost. And the cost, that the considerable more expensive purchase price than the comparable CRTs, which is cheaper lifetime cost that last about 13,000 15,000 more hours than a typical CRT here. The next is your grayscale. In grayscale, that have an irregular intensity scale and typically produces fewer than 256 discrete intensity levels for some LCDs, portions of the grayscale that may be desilted. The another one we have is the seventh one, which is your that is motion artifacts. Motion artifacts. In the motion artifacts here, that slow responsive that times and scan rate conversion that results in severe motions artifacts and the image degradations for moving or rapidly changing image. The eighth we have is your resolution. And resolution that work best at a native resolution, and the native resolution that cannot be changed. All other resolution that require adjusting procedure which can cause considerable deteriorations of the image. The ninth we have as your viewing angle. In the viewing angle, that the restricted viewing angles affect the brightness, contrast and the color shown. The wide angles that can lead to a contrast and a color reversals as well. The another one we have is your, that is the 10th one, which is your white saturation. In white saturation, that the saturations and the compression that can occur due to the bright end of the intensity scale that becoming overloaded, and the contrast control that must be careful adjusted as well. So the LCD demerits that we'll discuss about it, which is the first, that aspect ratio, second black level, third contrast, fourth color and grayscale accuracy, fifth cost, sixth grayscale, seventh motion artifacts, 8th resolution, 9th viewing angle, and the 10th is your white saturation as well. Now we will go ahead with other question that what we have to talk about it, and which is another question is that if base address of a frame buffer is 100 and screen size is 15 inch and 19 inch with resolutions in 13 dpi, which is dot per inch, that calculate the memory location where the coordinates of the pixels are stored. So the pixel P1 at A, that is your 200, 25, pixel P2 at B, which is 75, 45. So now we'll go ahead with solving all these questions here. So the questions we have, if base address of a frame buffer is 100 and screen size is 15 inch into 19 inch with the resolution in 13 dpi, which is dot per inch, then calculate the memory location where the coordinate of pixels are stored. The first we have, that is pixel P1 at A, that is your 200, 25. So for that we'll solve it out first. So the base address is 100. The resolution of the screen is 197, 247 pixels a dot, that will solve it out here, and memory locations of P1 equals to memory location of P1 equals to base address plus 198 200 plus and that 25. So when we'll multiply by 200 and then of course then we'll plus add on 2, so we'll get that will 39725, and we'll multiply 198 by 200, we will get 39700, and we'll add 25, so 39725. You can just go ahead. Let's go ahead with other one. That is another question in the SIS, only the sub question that has been asked. The second part, that is your pixel P2 at B, which is 75, 45. So here the base address is your 100. Resolution of the screen, that as I told you about 197 into 247 pixel or dots. So the memory location will find out directly. Memory location of B2, which is equals to base address plus 198 abstract 45 plus 75, that is equals to, in this here when we multiply 198 with 45, we will get that is your that is 9010, and then we'll add 75, so we'll get 9085. So that will be here the answer. Now we'll go ahead with other question, that what we have to talk about it as well, and that is the another question, which is to calculate the value of pixel, which is a scan curve converted by DDA algorithm, and endpoint of line is 4, 4 and 3 minus 3, 0. So for that we have to find out, and we'll have to plot it out as well. So let's go ahead with the question. This is a long question, that's the reason that they had asked you about this question of 10 marks. That is, calculate value of pixel, which is the scan converted by DDA algorithm and endpoints of line is 4, 4 and minus 3, 0. So now for that we will be having a solution here. In this, that we have x1, y1, so here that the solution we have, as I told you about it, which is x1 and y1, that is equals to minus 3, 0 and x2 and y2 equals to 4, 4 and delta x is equals to 4 minus 3, that is minus plus, so 4 plus 3, which is equals to 7. Delta y equals to 4 minus 0, which is equals to 4. So length equals to delta x, and that is the delta x equals to 4 minus 3 upon 7, so 4 minus plus 4 plus 3, that is 7 upon 7, so it will cancel it out, we'll find it out as 1. Now we'll talk about delta y, which is equals to 4 minus 0 upon 7, so 4 minus 0 is your 4 and 7, that is 7, so 4 upon 7, and if we solve it out, that is 0.57. For the x, we'll go talk about it, what we had talked about as well. X equals to x1 plus 0.5 into sine delta x, and that is x1 is minus 3 plus 0.5 sine delta x, we have a 1, so that is your, in the same cases that will put the value, and that is your multiply 1. and we'll get it, that is 0.5 plus 1, that is your 10, and then minus 3 and plus minus 10, that is your 2.5. 0.5 multiplies, that is 0.5 only, and minus 3 plus the 3 में 0.5 जाएगा, 2.5 बचेगा. Okay, that will be the answer. For the y, that is equals to y1 plus 0.5x, sorry 0.5 multiply sine delta y, and for that we have 0 plus 0.5 multiply, which is your 0.57 equals to 0.285, and that we have. Now have to plot integer minus 2.5 and 0.28, and that is minus 3 comma 0. So x equals to x plus delta x equals to minus 2.5 plus 1, which is equals to minus 1.5. And for that as well, that for y equals to 0.85 plus 0.57 and equals to 1.42. Now we'll plot integer, which is your minus 1.5, this is 2.5 minus 1.5 here, and 0.85, that is your minus 2 comma 1. So for that, x equals to x plus delta x, which is minus 2.5 plus 1, which is equals to minus 1.5, and for y, that is equals to 0.85 plus 0.57 equals to 1.42. Now for the another one, we'll find it out here as well, and in the same cases, that is the another one, and in the reference towards it, that what we have to find it out in each and every one, that is to be very clear about it, and in this respective manner, that what we have to solve it out as well. So here that we have that is here, that is when this is 0.85 not, it is 0.8, this is 2.28, 0.28 plus 0.57, then we'll add it out, so it will be 0.85 here. So that we'll go ahead, and that is the another one we have, and that is 1.42 here. Now for the another plotting, we'll have to plot it out, which is plot integer minus 0.5 and 1.42, that it is minus 1 comma 1, and for that we'll plot it out, which is x equals to minus 0.5 plus 1, which is equals to 0.5 itself, and for y, that is equals to 1.42 plus 0.57 equals to 1.99. Now for we'll plotting out with plot here, that is your plot for the another one, and that we have as to be follows, and that is in the reference towards it when we're falling out, and that is in plot integer 0.5 and 1.9, that is 1.2, x equals to 0.5 plus 1, which is equals to 1.5, y equals to 1.99 plus 0.57, that is equals to 2.56. Integer that is of 1.5 and that is and 2.56, that it will give you that it is 2.3, and for that we put the value here, which is x equals to 1 plus 1.5, which is equals to 2.5, and y equals to 2.56 plus 0.57, that is equals to 3.13 as well. In the same references, let's go ahead with other one, that is your plot integer, which is your 2.5 and 3.13, that it is, we have 3 comma 3, x equals to 2.5 plus 1, which is equals to 3.5, and y equals to 3.13 plus 0.57, which is equals to 3.7 here. Now we'll plot integer, which is 3.5 and 3.7, and that is your 4 comma 4. So in the same references here, we'll plot a graph here that is very important as well, and that will go ahead as well, and that is we are plotting of that particular graph, that what we have to consider about it, and which is in the form of 0, 1, 2, 3, 4 and 5. This is x-axis, this is y-axis, where we have 1, 2, 3, 4 and 5. This is minus 1, minus 2, minus 3, and so on. So it will come from minus 3, then minus 2 comma 1, which is here. Then we will plot the point and then we'll do it. So minus 1 comma 1, which is here. Okay, then other comma is which have 1 comma 2. So 1 here, 2 here, so 1 comma 2. Then we have 2 comma 3. So 2 here, 3 here, so 2 comma 3. And then we have 3 comma 3. So 3 comma 3. And then we have your 4 comma that we have 4 comma 4. So 4 here and 4 here, so that will be, so we'll join all. So this is the graph that has been represented here. Now the other question has been asked for the another 6 marks here, that write the Bresson-Hum's algorithm of a line and explain, that we had done in unit 1. And the other question has been asked, explain the Sutherland-Cohen's that line clipping algorithm, which also we had done in unit 2. And the other question is differentiate between the raster and the vector graphic, which is from unit 1, which we had done. The other question is that write any 2 parts of the following and there, and that has been asked. So the question is explain the Phong and a one model for the illumination, which has also been of 6 marks, and the Phong model we had done in unit 4, and a one model also we had done in unit 4 as well. So let's have the other question, that is less PO, that is your we can say that the P or not and P0, that is your P0 comma 0 here as well. And in the same cases we'll deal with it many detailed in it, and where we have to do many of the questions as well. So we'll go ahead and we'll write it on question, and first I'll be just telling you about the question here, which is let P0, that is your 0 comma 0, and P1 is your 1 comma 2, and P2 is equals to 2 comma 1, P3 equals to 3 comma 1, P4 equals to 4 comma 10 here, and P5 equals to 5 comma 5. The given data control point, the interpolation based on the Bayes curves is used to find a curve interpolating these data points. So find the parametric midpoint of the gradient and also calculate the coordinate of a parametric quartiles of the curve as well. So let's go ahead with the question here. So let P0 be 0 comma 0, P1 1 comma 2, P2 2 comma 1, P3 we have your 3 comma 1, and P4 we have 4 comma 10, and P5 is just 5 comma 5. Be given data control point that if interpolation based on Bayes curve is used to find a curve interpolating these data points then find parameters, that parametric midpoint of the gradient, and also calculate coordinate of parametric quartiles of the curve. So this is a question, and now we'll go ahead with the solution as well for this, because this has been asked of 6 marks and that is also an important question in reference towards it. So let's go ahead with the solution. That is a little bit long, but we have to do it, and because this has been very important as well. So here we'll go ahead. So here the solution we have, which is the given points that we have is your, as I told you about P0, P0 is 0, 0, P1 is 1, 2, and P2 is equals to 2, 1, and P3 equals to 3, 1, and P4 equals to 4, 10, and P5 equals to 5, 5. That has to be represented here, and for that we'll find out the solution as well, and that for the solution that we have here, and that we'll find that u equals to here, that is your 0.5, and that has to be named as well. And then after that we will be having a further one on the respect towards its only, and that what we will have to go through with that. So here u equals to 0.5 and n plus 1 equals to 6, and that is your n equals to 5, and that is your p0, p of u equals to 6 sum of 5, where n equals to 0, sorry, that is k equals to 0, p of k, y equals k, comma n of u. So for that we'll talk about it. Y equals k, comma 5 of u, that is equals to c 5, comma k, u power k, 1 minus u, n minus k, and we'll find out for this c 5, comma k equals to addition of k 5 minus k as well, and that b 0, 5 of u, which is equals to c5, 0, u0, 1 minus u, 5 minus 0, which is equals to 1 minus u 5. The other we have p 1, 5 u equals to c5, 1, u1, 1 minus u4 minus equals to 5 u 1 minus u power 4. The other we have p 2, 5 u equals to c5, 2 u power square, that is 1 minus u power 3 equals to 10 u square, 1 minus u power 3. So b 3, 5 u c 5, 3 u power 3, 1 minus u power square equals to 10 u power 3, 1 minus u square. Then b 4, 5 u c 5, 4 u the power 4, 1 minus u power 1 equals to 5 u power 4, 1 minus u, and then d 5, 5 u equals to c 5, 5 u power 5, 1 minus u power 5 power 0 equals to u power 5 here. So for that we'll find out for the c as well. So here the c we have c 5, 1 equals to addition of 5, 1 and 4, and that is equals to 5, combination of 4, 1 and combination 4. The other we have C 5 comma 2 equals to combination of 5 upon combination of 2 and 3. So with reference towards it here, which is your equals to 5 into combination of 4 upon combination of 2 and combination of 3. So it will give you 5 into 2, which is equals to 10. The other we have C 5 comma 3, which is equals to combination 5 upon combination 3 combination 2, which is equals to 10. The other we have C equals to 5 comma 4, which is equals to combination 5 upon combination 4 combination 1, which is equals to 5. Now at u equals to 0.5, so we'll find out x, that is 0.5 equals to 0 plus 1 multiply 5 multiply 0.5 minus 5 power 4 plus 2 into 10 multiply 0.5 power 2 0.5 power 3 here, then plus 3 multiply 10 0.5 power 4 5 plus 4 into 5 0.5 power 5 and plus 5 into 10 0.5 power 5. So with this same reference we'll get it, which is here, that is 0.5 power 5 5 plus 20 plus 30 plus 25, that is equals to 2.5. For the y 0.5 we have in this, that is equals to 0 plus 2 power 5 multiply 0.5 power 5 plus 1 multiply 10 0.5 power 5, and that is your plus 1 into 10 0.5 power 5, and that is your plus 10 into 5 0.5 power 5 plus 5 into 0.5 power 5, then that will give it as 0.5 power square 5, that is 10 plus 10 plus 10 plus 50 plus 5, which is equals to 85 multiply 0.5 power 5, which is equals to 2.6562. Now in the same references, then we'll go ahead here, and that is at u equals to 0.5, your x comma y equals to 2.5 comma 2.6562, that it will find it out. Now the other question has been arise that explain the various types of quadratic surfaces with the equation and a blobby object that we had done in unit 4. These were the question which we are solving right now today itself. These were that question that what we had not solved it out because we had not because these were the some of the question different that they had asked from their side. So these were those questions, and all the maximum questions we had done it, so we are not doing that, so you can go through with that as well. So the other question is that answer the two types of that has been asked of 7 marks, and you have to answer the two parts. The question is, what do you understand by the term concatenation of transformation? And concatenation of transformation, as you know, that we had done in the unit 2, and what are its advantages? So the advantages, the concatenation of the transformation we had done, that the advantages of introducing a matrix from a translation is that we can now build a complex transformation by multiplying the basic matrix transformation. And then they had asked you illustrate with a suitable example with a dot b, and that does not equals to b dot a, that they had told you about it. So let's go ahead to solve it. Okay, so concatenation of transformation we had done, and other than that we had the advantages I told you about it. And the question what they had told you is that you have to illustrate with a suitable example like a dot b does not equals to b dot a. So that what we have to solve it out here. So in reference towards it, if a matrix we have, that is your a matrix is equals to S00, 0S0 and 001, and B matrix is 100, 010 and H, A and 1. So A dot B, what we'll find it out here. So A dot B will be your S0 0 0 S0 and 0 0 1, that multiplied by 1 0 0 0 1 0 and H K and 1, and it will give you the matrix which is S0 0 0 S0 and then H K and 1. And when we'll multiply where the B and dot A, that will go ahead. So for B dot A equals to 1 0 0, that is 0 1 0 and H K and 1, that multiply S0 0 0 S0 and 0 0 1, and that will give S0 0 0 S0 HS KS and 1. So here we can see that A dot B equals to B dot A here. The other question has been arised here, that is another one is the applying the Liang-Basky to clip the line segment from A, that is a 3, 7 to B, that is 8, 10, and against the regular rectangle window P 1, 2 and Q 9, 2, and R is equals to, that is 9, 8 and S is equals to 1.8. So that has been the question here. So let's go ahead with question first, which is apply the Liang-Basky to clip the line segment from A 3, 7 to B 8, 10 against the regular rectangular window which is P, that is your 1, 2, Q 9, 2 and R 9, 8 and S 1, 8. So in this we'll have to go ahead with solution, and that what we have here. That is we have, that is this is your 0, 0. So here they have point which is 0, 0, and this is your 1, 2, this is 9, 2, 9, 8, and this is 1, 8. And this is your 1, 2. And there is a point 3, 7 to 8, 10. In the same references that has been represented here, what they had told you here as you can see, and in the same references now we'll solve it out for it, and that what we have even though, and for that we have a points that for the points 3, 7 and 8, 10, what they had told you about it. So the points are 3, 7 and 8, 10, and for that the rectangular window points are that we have P 1, 2, Q equals to, that is 9, 2, R equals to 9, 8, and S equals to 1, 8 as well. So where X max equals to 9, Y max equals to 8, X min equals to 1 and Y min equals to 2, and delta X is equals to X2 minus X1, which is 8 minus 3 equals to 5, and delta Y equals to Y2 minus Y1, 10 minus 7 equals to 3. x1 comma y1 equals to 3 comma 7, and x2 comma y2 equals to 8 comma 10. So here p1 equals to minus delta x equals to minus 5, p2 equals to delta x which is equals to 5, p3 equals to minus delta y which is equals to minus 3, and p4 equals to delta y which is equals to 3. The other we have is for the q1 equals to x1 minus x min which is equals to 3 minus 1, and that is equals to 2. Then q2 equals to x max minus x1, that is equals to 9 minus 3 equals to 6. q3 equals to y1 minus y min which is equals to 7 minus 2, that is equals to 5. And q4 equals to y max minus y1 equals to 8 minus 7, that is equals to 1. Now for that only we have another one, that is another one here in the respect towards it, which is your mu1 equals to r1 equals to q1 by p1 which is equals to 2 upon minus 5 and equals to minus 0.4. The other is for mu2, that is equals to r2 equals to q2 upon that p2, that is equals to 5 upon minus 3 equals to minus 1.66. That is mu3 equals to r3 equals to q3 upon p3, that is equals to 6 upon 5. The answer is 1.2. For the mu4, and that what mu3 we had it find it out, mu2 here and mu3 as well. So in the same references that we'll get for the mu1 which is equals to r4 equals to q4 upon p4 1 by 3, and that is 0.33. Now that mu1 equals to max minus 0,4 minus 1.66 and 0, that is equals to 0. And when mu2 equals to min 1 comma 1 by 2, so 0.33 equals to 0.33 as well. And if mu1 is less than mu2, the endpoints are visible. x1 dash equals to x1 plus delta x multiply mu1 equals to 3 plus 5 into 0 equals to 3. And y1 dash equals to y1 plus delta y multiply mu1 equals to 7, 3 into 0 which is equals to 7. x2 dash equals to x1 plus delta x plus mu2 which is equals to 3 plus 5 into 0.33 which is equals to 4.65. And y2 dash is equals to y1, that is your plus delta y into y mu2 which is equals to 7 plus 3 into 0.33 which is equals to 7.99. So visible lines will be having as your p1 3,7 and p2 equals to 4.65, 7.99 as well. Now the other question has been asked in this examination in the last paper, the last question as well, and that is your explain midpoint a circle algorithm, which we had done in unit 1 here. Now we'll go ahead with other question paper, that what we have to discuss here, and that is in the term of it, that is another one as well. So the question is to attempt all the parts of the section which is of 20 marks, and each question has been of 2 marks. The question is explain the role of the pixels as a frame buffer in a computer graphic, which we had done in unit 1. The other question is what do you understand by video controller, which is we had done in unit 1. 2 marks question. Justify the composite transformation, we had done in unit 2. What is a specular reflection, unit 4 we had done. Write the properties of baseline curve, we have done in unit 4. What do you understand by the raster scan display, which we had done unit 1. And write a rotation matrix about x, y, z axis in 3D, here we had done, and this question is in unit 3 here. The other question has been arised here. that is write the Bayesian sum algorithm for a line, that is we had done in unit 1, and give window to the viewport transformation matrix that we had done in unit 2. The other question has been asked is what is the persistence of phosphor, so that what we had not done. This is a new question that has been asked in the examination paper, so yes, we'll do that. Persistence of phosphor. So persistence of phosphor, that what we have to talk about it. In this, the persistence is defined as the time it takes in emitted light from a spin to decay of the 1/3 of its original intensity. The lower persistence phosphor require higher fresh rate to maintain a picture on the screen without flicker, and a phosphor with a low persistence is useful for animation, and a light persistence phosphor is useful for displaying the highly complex static pictures as well. Thus, in the other section that they had talked about it, which is that and the 5 questions from this question that has been each of 10 marks. The question is compare the computation done in digital differential analyzer, which is DDA algorithm, with Bayesian sums line drawing algorithm, which we had done in unit 1. You can go through with that. The other question has been asked is that is write a procedure for rotation and derive the derivations matrix for the representation about the x-axis. These 2 questions are from unit 2, which we had even though done. The other question has been asked is to consider 2 raster scan raster system with resolutions of 640 into 480 and a 1280 into 1024, and how many pixels that could be accessed per second in each of these systems of a display controller that refreshes the screen at the rate of 60 frames per second. That has been the question here, and in respect towards it, we'll go ahead with the solution. And that even though we had done a sort of like this question, but we are not done this one, so yes, you can go through with that as well. The question, I will write it down first. Consider two raster scan system with a resolution of 640 into 480 and 1280 into 1024. How many pixels could be accessed per second in each of these systems by a display controller that refreshes the screen at a rate of 60 frames per second. So we shall have a solutions here as well. The number of the pixels in one frame resolution, that is your resolution, equals to number of columns, that is your width, multiply number of rows, which is your height. So the number of frame per 1 second is just 60 frames, and hence for the resolution we have 640 into 480 that we had that they had told you about. So the number of pixels equals to 640 into 480 into 60, that is equals to 18432 pixels. This zeros, this is 0 from here, 1010, and 14 fours, and then 6, so that will be 1432 here. Now with the other one, this is what we have to find it out for the resolution of 1287 1024. So for that we have number of pixels. This is for 640 into into 480, and this is for 1280 into 1024. So the number of pixels equals to 1280 multiply 1024 into 60, so that is equals to 2 zeros last, so we will put that for the pixel, and then we have 786432. This will be the right answer. You can just multiply. And now the other question has been asked, write an algorithm for the Cohen-Sutherland line clipping algorithm and compare it with Liang-Barsky line algorithm, clipping algorithm. So Cohen-Sutherland algorithm we had done in unit 2 in a detail, and the comparison Liang-Barsky generally is more sufficient here, because Liang-Barsky that updates u1 and u2, and that are a one division window, that the intersection computed only once with the final u1 and u2. And Cohen-Sutherland, they may repeatedly calculate the intersections along the line, and even if the line is totally exterior to the clipped window, and each intersection computation uses the division and multiplication as well. In the same references, the other question has been asked, what is window to viewpoint coordinate transformation, and what were the issues related to it. In this, that the window and the viewport coordinate transformation, which we had thus in the unit 2 here. And in the same case for the issue, if I'm talking about, yes, that the two issues related to the windowing method are the worth nothing, and the first is the window length, and the length of that should be the greater than the effective length of HRIS, and the window length that can be effectively reduced under the minimum phase approximation. And the second issue is window shape. Windowing HRIS as the time domain is equivalent to the convoluting the corresponding HRTX with frequency domain representations of window function, and the simplest window is a rectangular window defined here, and here we can say that about it. The other question has been asked here, which is in the terms of it, which is to explain the parallel and perspective projection, justify the depth curling that projections for the 3D display method, which we had done in unit 3rd. The other question is, what are the criteria that should be satisfied to be a good drawing algorithm, explained in detail, which we had done in unit 1. In the same references here, that is, the other question is to explain the midpoint circle generating algorithm, which we had done in unit 1 as well. In the same references, if I'm talking about in a detailed here, and in the in reference towards it, another question has been asked, like, list the advantages and disadvantages of a back phase detection and a buffer method. What are the algorithm for the back detection, phase detection algorithm here? So back phase detection algorithm we had done in unit 4. And in the same references for the advantages of back phase detection, that is it is a fast and it is simple object space method. Disadvantages of the back phase detection is that it can only be used on solid object modeled as a polygon mesh, and this is most general modeling construct for the scanline graphics system. It works fine for the convex polyhedra, but not necessary for a concave polyhedra as well. These were the two disadvantages and advantages of the back phase detection as well. Where in the same cases, we'll go ahead with the advantages of buffer method and disadvantages of buffer method. In the advantages of buffer method, that it is an extension of the ideas in the depth buffer method. More than one surface intensity that can be taken into the consideration at each pixel position. It is also initializing the object edges. It has two fields, depth field and intensity field. In these surfaces and subdivided into a polygon, that mesh has been clipped against the pixel boundary, and the intensity of the pixel that is determined by considering the opacity parameter and percentage of the overlap to the overlapping of surfaces. These were the 7 advantages of a buffer. The disadvantages we have, the first disadvantages, since the algorithm processes multiple objects at a time, the total number of the polygon in a picture that can be arbitrarily large as well. Now the other question has been asked here, which is to different illumination that what they had told about it. So I think that we'll discuss in the next coming class, but that will be so faster here that we have to deal with it as well. So in this, that the question has been asked is, you are to explain the different elimination method and a different rendering method in detail, write its advantages and disadvantages. The elimination method we had talked about it, and yes, rendering method we have to talk about it here. So we'll go ahead with first here, that is rendering method. In the rendering method here, that the first we have is your scaline rendering and rasterization. in this, that a high level of representations of an image necessarily contains the elements in the different domain from a pixel, and these elements are referred to as primitive. In a systematic drawing, for instance, that the line segments and the curves might be primitive. In a graphical user interface, that window and a button might be a primitive, and in a rendering of the 3D models, triangles and polygons in a space might be primitive as well, where in the case that the rasterizations is frequently faster than a pixel by pixel rendering. First, the large areas of the image may be empty of primitives. Rasterization will ignore these areas, but the pixel by pixel rendering must pass through them. And the second, rasterization that can improve the cache coherency and reduce the redundant work by taking the advantages of the fact that the pixel occupied by a single primitive that tend to be a contiguous in the image. The other we have is your second one, which is your ray casting. In the ray casting, if I'm talking about here, and that is your ray casting, that is in a ray casting that the geometry which has been modeled is passed and pixel by pixel and line by line from the point of the view outward, and as if casting ray out from the point of view when an object is intersected, and the color value at a point may be evaluated using several methods. In the simplest, the color value of the object at the point of the intersection that become the value of that pixel. The color may be determined from the texture map, and a more sophisticated method is to modify the color value of the illumination factor, but without calculating the relationship to the stimulated light source, to reduce the artifacts and a number of the rays of slightly different directions that may be averaged as well. The other we have is the third one, that is your ray tracing. And ray tracing here, that the ray tracing aims to stimulate the natural flow of the light, interpreted as of particles. Most of the methods are path tracing and a bidirectional path tracing, or a metropolis light transport, but also semi-realistic method are in the use of the like whitened styled ray tracing or a hybrid, while most implementations let light propagate on a straight line application exists to stimulate the relativistic space-time effects as well. In a final production quality, that rendering of the ray traced work, multiple rays are generally shot for each pixel and traced not just for the first object of introduction, but rather through a number of the sequential bounces, and using the known laws of the optics, such as an angle of incidence that is equals to the angle of reflection, and more advanced law that deals with the refractions and surfaces roughness as well. So now we'll discuss about the advantages of rendering method here. In the rendering method, the advantages we have that ray tracing popularity stems from its basis in the realistic simulations of light over the other rendering method, such as scanline rendering or a ray casting effect, and such as reflections and shadow, which are difficult to stimulate using the other algorithm that are a natural results of the ray tracing algorithm, and the relatively the simple to implement yet yielding impressive visual results. And ray tracing often represents a first for ray into graphics programming, and it has the ability to shoot more arrays on a needed perform that anti-aliasing and improve image quality where needed. Disadvantages of rendering method, that are serious disadvantages of the ray tracing's performance, scanline algorithm and the other algorithm that uses the data coherence to share the computation between pixels, while ray tracing normally starts a new process treating each eye ray that separately. So advantages of illumination method, we have fast acceptable results and hardware support. Disadvantages of illumination method, which we have point light source, no interaction between objects, and ad hoc, not based on the model of the light propagation as well. The other question has been asked is your compare and contrast amongst B-spline, spline and Bezier algorithm for the curve generation, right? An algorithm for the Bezier curve generation here. So you have to get 4 control point, that is A, XA, YY, and B, XB, YB, C, XC, C, and D is XD, YD. So you have to divide the curve represented by the point A, B, C, and D into two sections as well. So with that same cases, we have an XA comp AB, that is we have your that is XA plus XB by 2, and then YAB, that is YA plus YB, that is Y2, and X that BC, which is XB and plus Y XC by 2, and YBC, which is YAB by C plus YB2, and as well as that is XCD, which is XC plus CXD by 2, where YCD, which is YC plus YD by 2, and where XABC, that XAB plus XBC by 2, by ABC, which is YAB and YBC by 2, XBCD, which is XBC plus CD, that is by 2, XBCD, XBC and YCD by 2, and XABCD, that is XABC plus XBCD by 2, and XABC plus YABC, that is your XABC, XYBC by 2, and then of course XABCD, XABC and plus YBCD, and that by 2 here. Then we'll repeat this step for the sections A, AB and ABC and ABCD, and the section ABCD, BCD and CD and CD here as well. And then after that we have to repeat the steps until we have a section so short that they can be replaced by a straight line, and replace small sections by straight lines, and then we have to stop it out as well. Then after that we have one question here, that is we have the differences between the B-spline, biases and spline, that what we have to be discussed here. So the last question, B-spline, that is your B-spline curves that are specified by a Bernstein specific function that has limited flexibility. In biases, the biases curve that can be specified with boundary condition without characterizing the matrix or with a blending function. In a spline, that is spline curve that can be specified by a given set of coordinate position that called the control points, which indicate the general shape of the curve. The second is that the curve resulted by the use of the open uniform, and that is based on the nearly like Bézier's curve. The curve generally follows the shape of the defining polygon in Bézier's, and spline that the curve follows the general shape of the curve as well. In the same cases, that another one, the third difference we have, these curves can be used to construct the blending curve. Bézier's curve that are commonly found in the painting and drawing packages as well as CAD system. In spline, that the typical CAD application for the spline includes the design of the automobiles, bodies, aircrafts and spacecraft surfaces, and the ship hulls as well. In B-spline, that is the B-spline allows the order of the basic functions, and hence that the degree of the resulting curve in independent and the number of the vertices. In the Bézier's, the degree of the polynomial defining the curve segment is 1 less than that the number of defining polygon point. And in third, that is your B-spline, that it possesses a high degree of smoothness at place where the polynomial bases connect here. So these were the 4 differences in terms of it that we had talked about it. This is the last that we had completed your computer graphics, and this is the last class of computer graphics as I told you about it. And in this, that we had completed unit 1, which is your graphic devices, unit 2 transformation, unit 3 3-dimensional, and unit 4 curves and surfaces with very short types of questions as well. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.